Okay, first let us start the services of this Kafka. Then later we shall try to see the producers, consumer as external applications. Okay, in this session we shall try to see how to run this producer and consumer as external applications, not from console, from externals. Okay, first let us go to the Kafka installation directory, Kafka, and this is where I have my Kafka home directory. And from here, let me start Zookeeper first. Zookeeper hyphen server hyphen start.sh, and with these configurations, I made these configurations here, properties. So with this, the Zookeeper service is going to start. So remember, Kafka cluster has to be maintained by Zookeeper. Zookeeper service is going to act as a coordinator, coordinator for all the services that run in a cluster. Okay. Next one. Next, we shall start the servers. Kafka broker server process or server process. What is this resource manager? Yes, Zookeeper. Kafka hyphen server hyphen start.sh, and the config server one dot properties. So I'm starting one server, first server, and next let me start one more server, bin slash kafka hyphen server hyphen start.sh with configurations server 2 dot properties. Sorry, something went wrong. Config slash enter. Yes, second server has started. Let us start one more server. We have three servers here. Bin slash kafka hyphen server hyphen start dot sh config slash server 3 dot properties. So we have started Zookeeper service and three servers, three brokers or three servers are running now. Okay. Next, the next step, we need to create a topic. Okay, we need to create a topic. So how to create a topic? We now have the idea. Bean Kafka hyphen topics.sh. Kafka topics.sh hyphen hyphen create hyphen hyphen topic. The topic one. Let us write test topic one, test topic one, and the topic is divided as partitions. So we need to provide that parameter also. Okay, partitions. Into how many partitions the topic has to get divided into. Let us say as we have three servers, let us have three partitions, and replication factor also has to be mentioned here. Replication hyphen factor, even let us go with this. Okay, three partitions and three replications, so totally 9 partitions have to be created. Okay, so one topic made up of three partitions, and three each partition again three copies, and we need to give this information to Zookeeper. Wait, what? So with this the topic has to get created. Yes, this is how the topic is created, test topic 1. Next, let us see what is the status of this topic, how the partitions are being allotted to the servers. Let us see them. So to see describe the particular topic, use this command describe hyphen hyphen topic, the topic name test topic. So hyphen hyphen topic test topic and Zookeeper. localhost or 2181. Sorry, just a topic. Sorry, just topic one. Sorry, just a topic one. Okay, this is the information about that. So three partitions and three servers and three replications. This is what happens. Okay. Now, so for like us, let me explain on the board. Mm, okay, this is like what three servers, three servers running in the cluster. One, two, three. First server, second server, and third server. And how a server is identified, how this process is identified. Each process is identified in a cluster, okay, or in any service or anywhere. Each service is identified by hostname and port number. Okay, hostname and port number. What is the host name? What is the port number of this server 1, server 2, and server 3? What are the port numbers? Do you have any idea? No, no. Okay, actually the default values will be like this. Okay, so I have configured the port numbers to be 9091, 9092, and the port number of service server 3 I have configured to be 9093. And these must be you know this must be accompanied with the host names, or host name, or if not, IP address. Okay, but no more in real time in production they don't use IP address, they use host name only. Okay, but I'm using IP address here. So my IP address would be like this: 172.16.38.131. Okay, so IP address colon 9091, IP colon 9092, IP colon 9093. So this is the identification of server 1, this is the identification of server 2, and this is the identification of server 3. And what is the identification of zookeeper? That would be 172.16.38.131 colon, its port number is, default port number is 2181. Okay, this is the zookeeper service identification, and these are the identities of the services running in the cluster. Okay, so what is the node I am running all these services is, this is the node whose IP address is 172.16.38.131, and this is the node where I'm running these four services: zookeeper and three servers. Is it fine? Just let me show you the port numbers. This is the first server. We can observe somewhere here. Mm, we can see this one here: 172.16.38.131.9091. This is the identity of the first server. Okay, broker 1, register broker 1. And similarly, second server, second server, where do I find it? Here, we can find it here. And broker 2. This is a broker 2, and this is the identity of the second server. And third server, mm, we can find it here, 9093, and this is the broker 3. Got it? So three servers are running, and this is zookeeper. Zookeeper, we can find what the have port number at which this is running is 2181. Here you can find this. This is the port number at which zookeeper is running. Is it fine? No. So, and we have created one topic also, and we have created one topic. The topic got divided into three partitions. So one topic and three partitions. And how the partitions are divided? Just let us see the status once. Mm, we have described the partition, right? See here, partition 1, 0 is the identity of first partition, the second partition, and third partition. So the leaders are like this: 2 3 1, 2 3 1. So let me write like this: the first partition is available in 2 3 1, second partition available in the servers 3 1 2, and third partition as 1 2 3, 2 3 1, 3 1 2, and 1 2 3. So let me write like this. So the first partition is available in the second server, second copy here, and third copy here. Next, second partition P2, 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 and third partition here P3, P3, and P3. Totally we have five, sorry, six, I think, so nine partitions, sorry, nine partitions. And this is the first server is the leader for the third partition, second server is the leader for the first partition, and third server is the leader for the sorry, this is second, I think, P2. This is the second partition. Okay. So what is the leader? The reading and writing operations from the producer and consumer will happen from these servers. So because of them, which we call them as leaders. Okay. This leader is important here. See this one. S1 is the leader for third partition, server 1. Server 2 is acting as leader for first partition, and server 3 is acting as leader for second partition. Got it? Now, let us try to run both producer and consumer as external applications. Producer and consumer. Consumer. Producer publishes the data to the topic, and subscribes. Consumer subscribes to the topic. Producer publishes and consumers subscribe to the topic. So how this producer is going to publish the data to the topics? Okay, this producer, remember, in Kafka, the data is available in the form of messages. The data is available in the form of messages. Each record will be called as a message. Each record will be called as a message, and this message is made up of two fields. One field is called as key, another field is value. Okay, understand here? So each record will be called as a message, and each message will be of format key and value. Okay, key and value. I will let you know what is this key and value later, but remember here, each record will be called as a message, and each message will be a form key and value. Okay, two fields will be there for the is message, and because of this, the Kafka is also called as what? Publish subscribe messaging system. It publishes messages and consumer consumes messages. So producer publishes and consumer subscribes to the messages. Because of this, Kafka is called as publish subscribe messaging system. Is it fine? Okay, so remember this point. This is very, very important: key and value. Okay, now do we have any idea of serialization and deserialization, Hina? Serialization and deserialization. Any idea about them? This is the term
Yes,
that,
I do.
yes, you're fine, right? Okay, yes.
Yeah, but I want you to explain because your explanation is always bit different from the others.
Okay, okay. So this producer has to publish the data into a topic, okay, in the form of key and value. So during the publishing of data into the topic, this producer has to serialize key and serialize value. Okay, and what is the data type of key and what is the data type of value? Okay, no, the key data type may be anything and value data type may be anything. Generally the key data type will be always string. Generally most of the times it will be string, but the value data type may change. Suppose if we enter the data as something like 1 or 101, some IDs, let us say. So all these are going to be integers. Let's assume this is the data I have been entering. I've been passing through producer to the topic. So all these are integers. So here that data type of value is going to be integer. And if we are going to some enter some strings, let's say some welcome or something, welcome, spark, and Kafka. So these are all strings. Okay, in that case, the type of value is going to be string. Okay, type of value is going to be string here. Okay, so key will be maximum, most of the times it will be string. Why? Because it is going to take the name of it, name of the value. I will tell you what is the key is exactly just after this. What is the task we have now? After finishing this, I will let you know about key also. Okay, so producer has to serialize the data first. I will let you know what is serialization is. Okay, now let's say we have two nodes in the network. This is the network. These two nodes are connected with the network, connected in a network. Node 1 and node 2. Okay, let us say that these two are just remote locations are in some network. So I want to send some information, some Java object, whatever what we have running some Java application here. We are running some Java application. Here also we are running some Java application here. Let us say client side. This let's understand this is the client and this is the server. Okay, so we are running with some Java, we are working with some Java application. This is making request, this node is making a request some for some data, and the server is providing that service, that is giving the response based on the request of the client. Okay. Now the request has to go here and it has to give some response. How it is going to respond, give the response in the sense it has to give some data as the output. It has to give some data. Let us say this some banking application, let's say some banking application. So the client is requesting for some customer data, some customer details. Okay, some customer details. Now, so this server has to process it. It has to process, it has to look for the particular customer based on the identity. It may be account number, it can be some account ID, it can be something. Based on that ID provided by the client application, it has to search for the application. It has to search for that data, the customer data based on the unique ID provided by the client, and it has to pass the customer data, that particular customer data to the client, right? So how it is going to send this data? What in what form it is going to send the data? So can I call this particular customer data as an object? Can I call this particular consumer data as a customer data as an object? Okay, so each customer data will be an object only. It will be a JVM object. Why? Because we are writing Java application. Each customer data, each information, what information the server is trying to send, that information will be sent as an JVM object. Okay, now so JVM objects on the network, okay, on the network, they will not be transferred as it is. Okay, here it may be JVM object, Java object. Here also it will be Java object. In the nodes in the application, they may be act as Java objects, but when those are getting transferred on the network, okay, with that network, these JVM objects will not be transferred as it is. Instead, they will be converted into some bytes of stream. Instead, they will be converted into some bytes of string so that they can be encrypted. This includes what? Encryption as well as some compression. Encryption and compression. Okay, so amount of data has to be, size has to be reduced. At the same time, the data has to be transferred in the network securely. So the transfer of data from one node to another node in the form of an object. So the object that has to get encrypted and that has to get compressed. Okay, so this process is called, that is, conversion of a JVM object or a Java object into bytes of stream. Okay, conversion of a Java object into a bytes of stream is called as serialization. Is called as serialization. Okay, and the reverse process. So here, from the server, at the server side, the Java object will get converted into stream of bytes, and after passing here, the bytes will transfer up to the client, and here the bytes of stream must be converted back to and this Java object again. So here, at the server side, Java object has to be converted into stream of bytes, and here the stream of bytes must be converted back to Java object. Okay, so this process is called as serialization, and this process is called as deserialization. Deserialization. Okay, so what does the serialization deserialization involve? Serialization is conversion of Java object to the bytes of string. This involves encryption as well as compression. Okay, data size will be reduced, at the same time data will be encrypted also. In order to protect it on the network, encryption will be used. In order to save the space, that compression will be used. We shall discuss about that later also. So the data gets serialized, and here, and again from this it has to form the original object again. That process called as deserialization. Okay, so exact similarly here, here also, the producer is publishing the data into topics, into the partitions. So everything has to happen in network here, right? Everything has to happen network. All these nodes are connected in network. Even producer may run on some another node. Producer won't run generally in these nodes. Okay, this is the cluster. Actually, this is the cluster where all the services are running here. Producer does not run here. Producer runs outside this cluster. So this producer has to run on some another node, some xyz node. Okay, so the whatever the producer is processing and publishing the data, that data has to travel in the network, and it has to reach the partitions. So the network, so Java object, the data has to be transferred in the network and to reach the partitions, these nodes. So obviously the data has to get serialized here. The data has to get serialized. Okay, similarly, the data has to get deserialized. Where the data has to get serialized, deserialized? At the consumer side. Producer side, the data has to get serialized. At the consumer side, the data has to get deserialized. Deserialized. Okay, remember that point. So uh, producers can be on multiple nodes. Yes, they can run on multiple nodes. That depends. That depends. They can run on single node or they can run on multiple nodes. It runs an application. It runs as a Java application. Simply, it runs as a Java application. It can run on one node or it can run on multiple nodes. Okay, multiple nodes also, any number of nodes. And similarly, consumer can run on one node or multiple nodes. It should run on as, it is a simply a Java application. Remember that it is simply a Java app. That's it. Okay, we can run anywhere where Java is installed, but they we must to make a binding here. We must make a binding between the application running here. If producer is running on this node, then we must make a binding here. Okay, the network must be established between the node available here and this cluster. Then only we can pass the messages. When then only producer can publish the messages to this partitions. Is it clear? So understand this point here. Producer has to serialize the data. Okay, and consumer has to deserialize the data, isn't it? So here, serialization has to be mentioned separately for key and value. Deserialization has to be mentioned separately for key and value. Okay, remember that point. Just let me make you clear with this. Okay, in our case, and consumer producer and consumer. In between this we have the cluster. Producer producing the data to Kafka cluster, and consumer subscribing the data from the cluster. subscribing to the topic. So here producer publish the data in the form of key and value. Each message, this is called as a message. So message has to get serialized. That means what? Key has to get serialized, and value has to get serialized. And here also, uh, consumer has to pull the data, key and value, even now message. And when it reaches the target system, when it reaches target system, this will be in serialized object only. But when it reaches the consumer, that is called as when the data is pulled by the consumer and writes into some destination, and again here the key has to get deserialized, that is message has to get deserialized, that nothing but message has to get deserialized, that is key has to get deserialized and value has to get deserialized. Okay, serialization is what? Remember that serialization is the process of converting a Java object or a JVM object into bytes of stream. Okay, and deserialization is the reverse process of that. That is converting a bytes of stream into what you call as a JVM object. So what do we do with serialization? Is what will happen with serialization is data size gets reduced. Okay, and some what you call as encryption will be added to it. That is the data will be converted into some non-understandable format, cipher text. We call it as cipher text, plain text, and cipher text. Got it? Now let me show you the code for it. Mm, so this is the producer. I think I have shown you already yesterday. Can you see this one? This is the first thing. This is the object we are creating here, producer one. This is the main method, and the very first thing is we need to provide the properties. That is configurations of the producer. What are the configurations that we are trying to provide for the producer? Okay, so producer has to write the data into some what do you call as server. Why? Because the partitions are being maintained by the servers. So here we have three servers actually, 172.16. You can observe this. So the servers have to be specified with the property called as bootstrap.servers. And how many servers we have? Actually we have three servers in the cluster. Okay, we have three servers. But do you think do we pass all the servers here? Do we need to pass the information of all the servers here, or just one or two will be enough? Now here on the server side, we have created topic, right? We have created a topic called a test topic one. The test topic one has been divided into three partitions, and those three partitions are available with the three servers. So okay, in this case, how many servers we need to mention with the producer? One or more? One or more? One would be enough. One would be enough. One would be enough. So one would be enough compressor. Okay, we need not to mention all this, but it is not recommended to go with only one server. It is always advised to go with minimum two servers. Let's say if we have let's say we have a partition in the production and in real time. Okay, sorry, some topic is there, and the topic got divided into 10 partitions. So let's assume these 10 partitions are available with 10 servers on 10 different nodes. Okay, so into how many nodes, sorry, into how many servers we are going to, this producer has to publish the data to. Do we need to pass all those servers IDs here, or is it enough to pass only one server ID here? Two. Why two? Why at least two? Why not one? Is there any problem with one server?
No, as you just said, it is not advisable to go with one.
Yeah, yeah. But we have to think about it, right? The thing is, see here.
Okay.
uh, suppose if we choose only one server, okay, let's assume we have chosen only one server producer. What happens if the server goes down while producer is publishing the data to it? Okay, what is this, what should happen if the server, let's assume we gave here only the first server, only one server id we gave here. So what should happen if the server goes down if producer is writing the data? Okay, so the data, the producer can't write the data. Why? Because the server is down. If the server goes down, the publishing of data to the partitions will be stopped by the producer. So in order not to do that, in order to continue the process of writing the data, if our server goes down, another server will try to accept the data. A second will take over. Exactly. Okay, because of that, at least it is recommended to go with two servers. One server, okay, it works fine, but it is not advised, it is not recommended to go with one server, at least two. Okay, that would be fine. Okay, now next, properties dot full, that is, um, now see here, we have the concept of what you call as acknowledgement. What is an acknowledgement generally? Okay, any idea of acknowledgement? Okay, now yes, it is exactly. So producer is publishing the data to one server. Let's say we have three servers as we have here. So it is publishing the data to one partition present in one server. So and when, let's, it has published one message, it has published only one message, and when this producer has to start publishing the second message, when it has to produce the second message, without taking the acknowledgement from the server, or with taking acknowledgement from the server, what is the guarantee that the message has been properly, what do you call as, published to the this partition? What is the guarantee that it may be lost, right? It may be lost before writing itself. That there are chances are there, right? There are chances are there. So this producer has to write the data to the partitions, okay, that it has to what do you call as, publish new messages only after accepting the receipt, only after accepting the receipt or receival of the first message successfully. If the first message is being, stored in the on the network or created in the server successfully, so these servers have to send a receipt acknowledgement that everything is fine, the data is created successfully. Then the producer has to create one more message now. So the servers will be sending the acknowledgements, and based on the acknowledgement, the producer is going to send the messages. Okay, this is what. Now, whether do you want acknowledgement or not? Whether you want acknowledgement, this acknowledgement or not, yes, that is message. Okay, I will tell you whether each message or a bunch of messages. I will come to that. Okay. So here, acknowledgement and the message. This fine. Now, so whether to accept, whether to invoke, whether to initiate this acknowledgement or not, whether to enable it or not. So if we write in the properties, if we write acknowledgement is equal to -1, let us say, if the acknowledgement value is -1, acknowledgement will be disabled, will get disabled. Okay, and if you write acknowledgement is equal to 1, acknowledgement is equal to 1, I will tell you what this is. And three values can be there for acknowledgement. It will be all, it will be equal to all. So I think this is 0, sorry, this is 0, not 1, this is 0. Okay, 0 is disabled, 1 and all will have three values for acknowledgement. Okay, so if it is 0, no acknowledgement, the producer does not wait for any acknowledgement. Okay, and if it is 1, if it is 1, I will tell you. So here we have partition, first partition is available in three servers, right? So producer will write only one partition into one server. Okay, so producer will write only one message into one partition, and this message has to be replicated into other partitions also. Okay, this message has to get replicated into other partitions as well. So total how many partitions must be created, sir? How many messages must be created now? Three copies of M1 must be created. Okay, so if you want acknowledgement, if you want acknowledgement after, after all the replications are created successfully, then only the server is going to send the acknowledgement. In that case, use the acknowledgement all. Otherwise, instead of that, only the first server, only after the data is created successfully in the first server, if the acknowledgement has to be sent without bothering about whether the data is replicated into the other servers or not. In that case, use this one, only one copy. Here all the copies. Okay, whatever the number of copies we have created for that particular partition, that is the replication. So if we say the replication as three replications have to be created, three copies must be created. Only after successful complete creation of three copies of data, then acknowledgement will be sent from the server to the producer. In that case, use acknowledgement value as all. And without bothering about the replications, only if one copy is created successfully, then send an acknowledgement to the producer to send next message. In that case, use the acknowledgement value as 1. And if you do not want to send any acknowledgement, then use the acknowledgement value as 0. Okay, got it? These are three values here. So based on that, I have configured the value here. See this, acknowledgement is equal to all. Get acknowledgement after all replications are made successfully, whether you can use 0 or whether you can use 1 here. Okay, but it is advised to go, recommended to go with at least 1 or all, not 0, 1 or all, at least 1. Okay, now next, properties dot put third property is client id. What is this client id? Some id for this application, some name, some unique id for this. This is the user defined value. It can be any value. Okay, it can be any some string. So some producer, some something, some user id. Okay, this is not a big deal. Next, retries. Okay, retries in the sense, you know what, suppose producer is writing the data to the partition, and if the server does not respond, it may be, that if the server does not respond, then what has to be done now? What has to be done? If the server does not respond, what has to be done? So if another server is available, then producer has to write the data into another server. But it won't take this decision immediately. Okay, it will make some attempts, it will make some retries. Okay, there may be some problem, always there may be some problem with the network. So if the server does not respond in a time, the producer is not going to take the decision immediately to switch over to another server. It will make some attempts. So do you want to retry? Yes. How many retries you want to make? So I gave the value as 4. So by default it will be one. I think only one by default the value will be. So we can configure that value to be 4 or anything that we wish according to our requirements. Got it? Okay. Next, batch size. So just now you asked me, is it for whatever I have written acknowledgement? Do you want acknowledgement for each message? Okay. So now here, when producer is writing the data to these partitions, okay, do you want the data to be written message wise for each message, or as a batch? Do you want to write the message, each message, or as a batch in the sense some collection of messages, some collection of messages? Got it? So a batch is nothing but some collection, some group of messages. Form a batch and then send all that entire batch at once. That is called as a batch. So producer can send message by message or as a batch. Okay, so what has to be that batch size? What do you want the batch size to be? Okay, that batch size we can mention in terms of bytes. What is the figure we have here? This is in terms of bytes. By default it will be some 16 kb, 16 kb. I have configured to some 32 KB. We can configure to be it to be any value, but the default value will be some 16 KB. Okay, this is called as a batch size. Okay, next one is the key serializer and value serializer. Just now we have discussed about the serialization. Okay, so key has to get serialized and value has to get serialized. So what is the type of serialization?
Just
Yeah.
I wanted to ask you this byte value, is it kind of a multiple of something or it is just random value?
Generally multiple of two. Multiple of two, something like, 2 power 1, 2 power 2, 2 power 3, 2 power 4. It is always an exponent of 2.
Okay.
Okay, when we have some memory also, we'll have 24, you got 4 bytes. We cannot have 5 bytes, 5 KB something. No, generally how
Even
do I
number.
say? Yeah, even not exactly even number. 2 power.
Okay.
2 power. Why? Because computer understands binary language, right? Binary language. So 2 power something, 2 power something, 2 power something, always 2 power something. Okay, 32, 64, 128, 256. All these are the values of 2 power something, 2 power something. Okay, it has to be power of 2. Okay, remember that. Next, this is the serializer. So the key is a string as well as value is also a string. Key is a string, value is a string. So I'm using string serializer and string serializer for both key and value. In the coming up sessions, we shall try to see go with some other serializers. We'll understand there. Okay. Next one, we need to pass a topic here. So what is the topic? Just now we have created there test topic. Okay, topic name to which the publisher has to producer has to publish the data to. And this is the creation of the producer object. We are trying to create a producer equal new Kafka producer of. This is the syntax for creation of a producer object. So we create a producer here, and with the what is this props? This is the properties. You can see this here.
Properties.
Okay, properties, the configuration properties, whatever we have set for the application, the properties we have to pass to this object. Next here, just simply this won't be used in real time, but generally I'm trying to show here. In the coming up session we shall see the actual processing here. I'm creating a message here, just called as welcome to Kafka. Some string I'm creating here, and this string I'm sending to for I equal to 1 to 10, that is 10 times this message. For every batch, 10 messages I'm trying to create here. For every attempt, for every running of this application, not batch actually, whenever I run this application, producer application, 10 times 10 messages, the same message welcome to Kafka will be sent for 10 times. Okay, 1 to 10. I'm writing here producer record. This is the syntax. Okay, data, new producer record of. This is creation of a record or message. A record made up of string and string, key data type and value data type. And the topic, what is the topic that you are passing? And message, this will be the message welcome to Kafka, and plus I dot to string. Can you guess what would be the output with plus I dot to string, message plus I dot to string? What is the I data type here actually? Ikkada. What is the data type of I?
Int.
Int, exactly right. So here what I'm trying to do is welcome to Kafka 1, welcome to Kafka 2, welcome to Kafka. 10 messages will be sent. So the first message will be like this: welcome to Kafka 1. Okay, I'm trying to concatenate this way. I'm trying to concatenate with this message with I, that is the value of I get welcome to Kafka 1, welcome to Kafka 2, Kafka 3, Kafka 4, like that. So I'm converting into integer. We cannot concatenate integer and string, so that is the reason I have converted that integer to string, I dot to string. Okay, and this is the function method to send that data. There is a particular message to the from the producer, okay, to the particular topic. Producer dot send of data, that's it. Okay, and after the messages have been sent successfully, then write this message, that is close the application, that is producer dot close. And finally I'm printing the statement successfully publish the messages to the topic. Got it? And this is about producer, and this is about the consumer. You can see this now. You can see the properties of this consumer. Exactly similarly, whatever we have written the properties for the producer, even we have to write the properties for this consumer also. Okay, so the very first property must be always this one. The way this is the mandatory property. Okay, without which nothing will be done. Okay, so bootstrap servers. So how many servers? So here we are passing the data to two servers, 9091 and 9092, and we are trying to read the data from consumer is reading the data from which server, 9093, that is the third server. So why? Because if producer successfully writes the data to the all the partitions, the data has to get automatically replicated. Okay, that is how we have created the topic, right? The topic has been divided into three partitions and it has been replicated into three servers. So any server should have the three copies of the partitions. Sorry, three partitions. So we can subscribe to any one server here for the topic. So it can be first server, second server, or third. So you can use anyone. And after that, you can observe here. Here we have key serializer and value serializer here. Key serializer and value serializer. And consumer where we should have key deserializer and value deserializer. Okay. So as we are using here string serializer and string serializer, here we have to use string deserializer and string deserializer. Okay, got it. And I will let you know about this group ID and heartbeat interval later. So because this is not going to that much show any impact on them. These are optional values. I will let you know in the tomorrow session. I will let you know what is the group ID and everything. But this one client ID, this also is some it is not optional. It is not that much important. But just understand what is this app is, some consumer application like that. Okay. After this, now this is the creation of a consumer object. So as we have created a producer here, producer equal to new producer of string properties. Exactly, we need to create a consumer object here. Val consumer equal to new Kafka consumer of properties. Okay, and the topic. So it is not a Kafka topic one. This is the test topic now. Test topic one. And here we are writing here producer dot send. We are writing producer dot send to send the data, publish the data to the topic. Here we write consumer dot subscribe. Subscribe to which topic? This is the topic. Consumer dot subscribe to the particular topic. This is what we have to write here. Okay. And why do we have collections here? What is a collection generally? What is a collection?
Group of messages.
Yes, group of messages. Okay, so here a consumer can subscribe to multiple topics. Remember that. Okay, a consumer can subscribe to multiple topics. So that is the reason here we are using collections. But in our application here we are using only one topic. We are using only the topic now. But in general, a consumer can subscribe to multiple topics. Remember this point. Okay. Now next one. So while true, what is by while true? What is this condition? What is this loop? While true, it is
Means if it is
if it is
true, the condition is true.
so condition is always true. While true is nothing but always true. We did not specify
Okay.
any condition. Just simply we said that true. That's it. So it will be
Okay.
continuous loop. It will be infinite. It's something like stream. It won't stop until we stop. The application is not going to stop. It is going to enter into infinite loop. Okay. While true is always, generally when a loop gets executed, as long as the condition evaluates to be true. But here we are not providing any condition. Simply we are saying is always true. So it will enter into infinite loop. Okay, so something like stream application. Stream is nothing but it's an infinite application, right? An application has to run infinitely. It has to enter into infinite loop. That is called as a stream actually. Okay, so for that we are using while true. And records equal to consumer dot poll. This is some polling. Don't worry about this. It is not going to make much deal. So consumer dot poll. And next here, what are the records that we are going to get from the consumer? Okay, what are the record that we are going to get? That records we are going to display here. So for every record, so for all the records, for every record the present in records, so I'm calling the set of records as records. and I'm loading into some variable called as the record, and I'm printing every record. This is very simple. Try to understand this logic, only this logic. This is the logic of actually receiving and processing the data. Okay, consumer dot poll and records dot iterator and received message plus record. That's it. Any questions in this code? Any doubts?
No, so far it's good.
Okay, fine. And finally, when the consumer, after pushing, pulling the data from it, commits synchronization. That is, it has to give some acknowledge. That is a synchronization. It is not mandatory. Let me come to that later. It will get confused here. Just let us deal with later. Okay, it is not required here at this point. So this is the main part here. Okay. So now what we shall do is we shall run the producer and we shall run the consumer both. So now what I do is first I start the consumer. So how do I run consumer? Um, mm, Run consumer one. Consumer one is starting. So consumer one has started here. This consumer has started. It has started. It has start. Just it has started now. So as you know, when the producer publishes the data, immediately this consumer is going to accept the data from it. Okay. So till now, no data has been produced by the producer, so it is not showing anything. So let me run producer. So here in VMware here we are running the services. Okay, but we are running producer and consumer out of that cluster. Okay, we are running on separate node, something like separate node. Okay, so let me run producer now. So I'm in producer program here, I'm running producer. So producer has said that successfully return the messages. Now see this consumer, can you see this? Can you see these messages? Okay, this is a consumer actually, and this is a producer, and this is a consumer. So what I'm saying here, received messages, topic test topic 1 partition 0, there is a first partition, offset value, I will tell you what the offset value is, and finally you will see last in the last, this is a key value is null, and value is welcome to Kafka 1 2 3 4, we'll have all the values here. Kafka 1, Kafka 2, Kafka 3, Kafka 4. I will tell you why we don't have this order here later, but and try to understand whether do we have all the messages or not. Okay, 2, 4, all the 10 messages we are going to have here. If you run producer once again, let me run producer once again. Then again we have to see 10 more. So it said successfully return the topic, and if you see consumer here, then again it will have 10 more messages. You can observe here. Previously we had 10, now we have 10 more. Okay, like this. Now can I make producer to write the data continuously as a stream? Can I make like that? Here we are writing only 10 messages and we're stopping the producer. Yes, we shall make that. What is that we have to make the changes here? It is instead of using only from 1 to 10, mm, we shall use like this. So what is the condition to make it as infinite loop?
While true.
While true, exactly. While true, while to do this operation, that's it. Okay, so let us run this now. Run producer. Okay, it is going to write the data. Something wrong, sorry, we don't have I here. mm, Let me delete this part here. Okay, fine. Why producer, and let me run producer now. Okay, so producer is running, producer started. So producer will not show that message that is completed. Why? Because we have entered producer into a streaming application. So we shall go to the consumer, you can see the consumer. So it is continuously getting the messages from producer. So it is going to show us continuously this message. You can see here. Okay, it will write the data continuously. So that's it. It's going to get the data continuously on the producer. So unless we stop the application, this application is going to be continued. That's it. Okay, are you able to see this? Okay, so actually the cluster is somewhere. So what's happening with this actually, the data, whatever the producer is publishing the data, that data is will be actually is being sent here.
So how do we stop it?
Okay, so here where actually all the services are running, so the data is getting published here, and from here actually we are pulling the data by using this consumer application. So producer and consumer applications, two applications are running outside the cluster. Okay, they're not running it outside the cluster, so they're making a connection to the cluster, the network. They must have a connection, network connection, so they must be connected so that they can run the applications. Okay, got it? Okay, just in the application what we are doing is producer, some sample data, some random data we are generating and writing into some topic, and from the topic we are pulling the data by using this consumer. Okay, but this won't happen. Just we are trying to display whether it is happening or not on the console. Just we are displaying it, but in real time we don't display the data. We store the data in somewhere, right? We don't just store the data somewhere. We read the data from some storage system or from some server. That is, producer has to pull the data from some server, and this consumer has to pull the data from the topic, and it has to write the data into some other application. Okay, another storage system. It is not producer and consumer not meant for just to display the data onto the console. These are only for our understanding purpose. Okay,
So,
fine. Yeah.
is it the information about the message, or where is the message?
Message, actual message information will be here. Can you see in the
Mm.
last? Yes.
Yeah.
Welcome to
So,
Kafka.
like,
Welcome to Kafka is in the last.
oh, okay, I cannot
Yeah.
see that. Okay.
Yeah. This is actually, I should drag this to the right side. You can
Right.
see this. Okay. So we'll have a message is made up of partitions. Already you can see the partition there, and topic name and offset value. What is my offset value? What is that
Let's
offset
start with.
value? Okay. Offset is, I will let you know that. Just let me explain you that. I think already we had discussion on offset, right?
No,
No.
no, but it is kind of a start beginning value.
Yes, exactly. Okay. Let us say this is the first server, second server, and third server. Um, so partition one, let us say partition one here, partition two, and partition three. So some message will be returned to this. Okay, the first message. So let me call these as partitions. Okay, these are the partitions, and this is the partition data. So whenever a new message enters here, M1, M2, M3, M4, M5, and these are the messages that get stored into second partition, M3, M4, M5. Let me call like this: M1, M2, M3, M4, M5. So the partition offset is 0. Offset value of second message is 1. Offset value of third message is 2, 3, 4, like this. It goes on increasingly. This is called as offset. Offset is the identity value or the index. The index or identity for a message in a partition. Okay, the identity or the unique value, or this are some unique value or index. We can call it as index of the message stored in a partition. That's it. Okay, 0, 1. This message will have the 2, 3, 4. These are called as the offset values. 0, 1, 2, 3, 4. These are the 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4. So it is going to give the offset value also. Offset, topic name, partition, and offset values. And along with that, it is going to show one was called timestamp also. I think you can see the create time here. That is called a timestamp. What is the timestamp? What are the units of this? We could see some 15, 2, 4, 7, 8, 6, 2, 3, something like that. What are all this? What is the timestamp? Which standard time it is? Any idea? Okay, that time is called as mm, epoch time. That time is called as epoch time. Okay, so that time is nothing but it is in milliseconds. It is in milliseconds, a milli or microseconds. I think in microseconds. Within microseconds, the units are microseconds. Starting from 1970 January 1st. Okay, so the number of microseconds till today, till now. Okay, what is the time, what is the duration of time in microseconds? That is called as the epoch time. So that will be taken as a timestamp. So each message will be accompanied with this timestamp also, in which standard? Epoch time standard. We can convert that into our time also, our required time zones. We can convert it into, we have many functions, we have many already functions are there, predefined functions. We can use them and we can convert into our standard time zones. Fine, it's clear. Any questions in this session?
No. So what's that Unix timestamp?
We can convert this now. This is the epoch time. By We can write the code. We can write the code in consumer so that it can be stored it as some Unix timestamp. It is a Unix time only actually, but it's not exactly that standard. It is the epoch time. Generally, whenever we take this all these Java applications, Kafka, Spark, Hadoop, and everything, whatever we take, they generally create the timestamp in this time standard. That is the epoch time. We can convert that into our unique timestamp, or our some any other timestamp whatever we require. We can convert it. We have many functions predefined. We can use them. I will show them. It's not a big deal.
So Kafka is also written in Java.
Yes, Java and Scala.
Scala
Java,
both. Okay.
Java and Scala both. Okay, fine.
Hmm.
Mm, so okay, shall we stop for today?
Okay, sure.
Actually, one point to make here, that is actually, yesterday your husband has called me. He was
Mm-hmm.
asking for some details about the bank. So I could not give the details properly. Why? Because actually I came to know that transferring the money